Welcome to Agam's lecture series, a series of lectures designed to bring learning to the comfort of your home. Today we are going to discuss the subject General Laboratory Techniques, GLT 111. These are introductory laboratory methods for the different natural sciences, namely there's chemistry aspect, there's biological aspect, and there's physics aspect. Today we are going to take aspects that concern what? Chemistry. And today we are going to discuss the topic glass. My name is your lecturer, Agama. Glass. This lecture is part 1. We are going to have other parts, part 2, part 3, as the case may be. Glass. What is glass? Glass is a fusion of sand, limestone, sodium carbonate or sodium sulfate, broken glass, potassium carbonate, and lead, in addition to magnesium oxide or selenium in light proportion. This magnesium oxide and selenium in light proportion is added to neutralize the yellow and green colors due to the presence of iron 3 and iron 2 oxide. That's what glass is. So a mixture of sand, limestone, sodium carbonate or sodium sulfate, broken glass, potassium carbonate, and lead, in addition to manganese oxide or selenium in light proportion. Why are you adding this and this? To neutralize the yellow or green color due to the presence of iron 3 and iron 2 oxide in the glass mixture. When glass is heated, when all these mixtures are heated, it will turn to molten glass. And this molten glass, when cooled at right temperature, it is poured into molds or rolled into different variety of shapes. You can have plates, you can have cups, you can have kettles, different shapes of glass. The rapidly cooled glass is brittle. Brittle simply means that it's liable to break easily. If you cool glass rapidly without cooling gently, the product that results will be brittle. That is liable to break. Silicon oxide, and silicon oxide is technically called sand. Silicon oxide, SiO2, melts at a temperature of 1700 degrees. Therefore, why we are adding sodium carbonate in this glass is to reduce this temperature, because 1700 is a very big temperature. You can't get it in most local industries. So you add this sodium carbonate to reduce the melting point of the sand. Then you also add calcium oxide. The essence of the calcium oxide is to render the glass insoluble in water. If you have tumbler, you are pouring water in it. If you didn't add calcium oxide, the glass will slowly be dissolving. But if you add calcium oxide, you make the glass insoluble in water. Let us remember that glass has no definite melting point. So it can melt at any given temperature, depending on other surrounding environmental conditions, like pressure, amount of heat, etc., etc. What are the common properties of glass? Properties of glass. What are those properties with which you know a glass? It's insoluble in water. Yes, as we have said. It's partially decomposed in water. Like if somebody give you a broken glass, some part of the glass can be dissolved in the water, and that says it partially decomposes in water. It's unaffected by acids. The only acid that affects glass is hydrofluoric acid. Acids are attacked by strong alkalis like sodium hydroxide, potassium hydroxide, calcium hydroxide. They are all alkalis. What are the uses of water glass? Water glass can be used in making soaps and detergents. Water glass is used in treating wood. When you treat a wood with water glass, it becomes fire resistant. It cannot easily be burned by fire. It can also be used as a glue for cardboard boards, like making of cartons used for packaging. Then what are the types of glass we have? We have ordinary glass. Some people call it soda lime glass. Others call it window glass. This glass consists of sodium and calcium silicates, as we have said. Potassium and barium can be substituted respectively. That means using potassium to substitute for sodium and using barium to substitute for what? Calcium. That's why I say can be substituted respectively. Then what is the formula for glass? Formula for what? Glass. In the exam, we can ask you to write the formula for glass. The formula for glass is sodium, calcium, silicate. And you can see the formula: sodium, 2 atoms, calcium, 1 atom, silicon, and 14 atoms of oxygen. So in the exam, if you ask to write the formula of glass, this is what we are going to write. Apart from this ordinary glass, there are other types of glass. Like there's one we call the flint glass, the hard glass, the Pyrex glass, the Bohemian glass, the quartz glass, or the out glass. Some of these glasses, you can also treat them to be used for another thing. For instance, reinforced glass. When you reinforce glass, you impregnate the glass with network of wires to make it what? Stronger. You can also what? Shatterproof glass. Shatter means that if you hit it, it will not break. It's not that the glass will not break. If you look at the window, window of cars, the front window and the back window, you said if you hit them with iron, they will not just pieces, because there is something inside that cements the two together, so that even if you shatter them, they will not fall out easily. That's why I say shatterproof, because it's cemented on both sides to a sheet of vinyl butyl. And this type of glass is used in what? Automobiles, vehicles. Then you have security glass. Security glass is a kind of hardened glass. If you see where police is quelling protests, like the death of George Floyd in America, you see police quelling protesters. That big glass they hold in their front to meet protesters is called what? Security glass. It is hardened so that it becomes a protective what? Shield. It's normally used by police. During the old days, some people can also use it in military warfare if people are using like rubber bullets that are not too strong. So they call what? Security glass. What are the advantages of glass? They are inert, as a good student of chemistry. If something is inert, something is non-reactive, that means here now we mean that they resist what? Attack by acids and alkalis, except hydrofluoric acid that we have agreed that they can only attack glass. They are transparent. You can look through a glass. That means that they are transparent. They withstand variations in temperature. You can keep them in a room temperature of 25 degrees, bring them under the sun at a temperature of 45 degrees, heat them even in fact, so they can resist. They can withstand what? Variations in what? Temperature. They are easily worked on with tools. You can easily work on glass with tools. They are light in weight. They are easy to clean. And generally, glasses are what? Cheap. If you go to ceramic industry, a place where they make glasses, glass is one of the cheap products to make. In these days of entrepreneurship, students are encouraged to go into glass making, because it's a cheap technology. Then what are the disadvantages of glass? They are brittle. That means they are liable to break. And they can also be attacked by hydrofluoric acid. Like I told you, they resist attack, but I told you they don't resist the attack of hydrofluoric acid. Then what are the common glasswares? Glass materials you can see in the laboratory, especially chemistry laboratory. You can see test tubes, you can see beakers, you can see flasks, and you can see different glasswares used in laboratory. Biology bio lab, physics lab, chemistry lab, microbiology labs. Then we're going to look at lubricants. What are lubricants? A lubricant can be petroleum jelly or Vaseline. It can be grease. It can be machine oil. It can be aerosol, which is not an anti-stick agent. It can also be vacuum grease. All greases are used to reduce what? Friction. What is friction? When two surfaces or iron are in contact, it leads to wearing and what? Tearing. That wearing and tearing is because two surfaces are rubbing themselves together and wearing and tearing the iron. To reduce this friction, you introduce what? A lubricant. And we have listed different types of what? Lubricants. Then cleaning agents. How do you remove these lubricants? You can remove this lubricant, especially grease and dirt, by using chromic acid. By using what? Chromic acid. We continue this lecture in this part 2, and we are going to deal with mixtures and separation of what? Mixtures in the laboratory. If you are thrilled by this lecture, click on the subscribe button and you get more of these lectures. Thank you and God bless you.